Hello there, thank you for joining me today. On the bench for a look at today is a Anritsu radio communications analyzer, which goes from 300 kHz to 3 GHz. This particular model is the model MT8801C. These test sets were primarily used in cellular radio testing and development. And today we're joined by the technical manager, who's just turned up to give us some technical guidance on operating this test set. He'll no doubt give his input at some stage in the video. Now the test set itself has got some hidden secrets in it, a bit like the video that I did for the Hewlett-Packard radio test sets that were basically developed for cellular industry, for the manufacturing and testing side, but this has again hidden analog features. Now towards the end of the video I'll reveal how much I paid for this test set, and you won't believe how little I paid, simply because of these hidden features which most people that sell these don't realise. Now if we just turn it on, but just before we do that, the test set itself is very heavy. It's quite a large test set as well. It goes a way back. It's probably 4 times as heavy as a standard Marconi radio test set is. It's definitely not meant for taking tilt-up radio masts, put it that way. So we'll turn it on and we'll have a look at some of the features and do some testing. And so we'll let it boot up. Now these test sets, you do see them knocking about on various auction sites and also at amateur radio rallies and such like. There's quite a few of them floating around, but like the many Anritsu instruments that are out there, they are very good quality, very well made, superb instruments. And this test set does boast a spectrum analyzer, which goes obviously the full frequency range of the test set up to 3 GHz. So you're getting an RF gen, TX power meter, spectrum analyzer, AF gen, AF analyzer, everything all inbuilt, just like the Hewlett-Packard HP892122 radio test set that I've already done a video on. And it's a very nice instrument indeed. It's got a TFT display, backlit, and you can choose various colours and schemes that the monitor will produce, and you can customise your own colour scheme on it as well. And there's quite a bit to it really. It's quite a nice little test set. So just for extra vision, we'll just reduce that backlit level there, and then we'll be able to zoom in. So what we've got the standard GSM measurements, cellular, all the parameters that you'd normally see on a cellular radio test set, and likewise with all these features down here. Now what we need to do to get into the secret analog functions is this main function here, and when we hit that to on, then we get analog tester, spectrum analyzer, and various other testers that we've got. TX tester, which is still for cellular. So if you press analog tester, and then we have TX measure, so we can basically look at transmit signals as well. We've got a full analyst there, so we can literally put a transmit frequency in. Then we've got the other options down here, which is to put the RF frequency in, AF levels, RF level and power, deviation, AF oscillator, and then up the side here we've got even more AF options. We'll just give you a quick rundown before we do some measurements. Likewise, also on the analog tester, we've got the RX measure as well, which again allows us to generate a frequency that we can put in. So we can select down here RF frequency, and you can enter in what you want. For example, I'll put 400 megahertz in, and then you've got your level as well, RF level. There's RF level on and off as well, and in the RF level mode you can use the up and down buttons here to adjust the RF level, or the wheel as well, and you've got the RF level there as well. And we can also select what outputs we want on the instrument, because there's an AUX input and output RF port, which gives us extra RF levels capability as well as the N type. We've also got the audio AF output and input as well, an AUX interface which we use for there's relays behind here which can switch pins on and off, so you can actually put a auto test on where it'll key a radio up to transmit, make a measurement and unkey automatically without anything. It's sort of an ATE, automated test environment thing. We've got a floppy disk drive for software and programs on there as well. Now if we just go back, we've also got we can set modulation up, we can set up RF level, RF frequency, AF level as well. There's quite a bit that we can set up. We've got the spectrum analyzer as well, which basically is 300 kilohertz to 3 gigahertz, and in here we've got all the facilities that we would normally have in the spectrum analyzer for measuring signals, markers, peak, fine, start stop frequency, center frequency, all kinds of different measurements, span, amplitude, peak find as well, peak search, so it'll find the right you know, where the signal is with that red dot there, it'll find. So it is quite a fully featured test set. Does so many things, not just analog but digital modes as well, and a very nice test set indeed. So again, we've got the hidden analog functions which you don't normally see on digital radio test sets for cellular, you know, for GSM. This does GSM tri-band, so it also does DCS and PCS 1800 and 2400, I think it is, megahertz as well. And you access these secret menus through these functions here. Now you can also get into the instrument setup as well, which I think if I press preset, and then I think it's down under instrument setup there, then you can set up the ports as well. Like for example, the RF input output is on the main, so that will be on the N type, or you can, if you want, you can select that for different configurations, so AUX main in, AUX out, main out, AUX in, etc. Once you set that, then it'll throw the relays inside, so it'll be on these ports now, and you get extra levels on that. And of course you can pick up off-air signals off the input now for monitoring off-air signals, so you can see those on the spectrum analyzer. And you can do such a lot with it. It's really a fully featured test set. There's so many things that you can set up in these parameters here, and then you can get into making all sorts of measurements and things. So again, I mean, this test set was primarily manufactured for cellular radio testing, and it was meant in the manufacturing environment rather than field service. But again, you know, I dare say you can load different software onto it through the floppy disk, you know, for various systems as well. There'll be somebody out there that's probably got the software packages for these. You can still get the service manuals for the instrument off Anritsu's website. There's various bits of software you can download for it still. There's quite a bit that you can get into. But again, it's a very nice lovely featured radio test set. So what we'll do, we'll connect up a signal generator now and do some measurements and show you its performance and different measurements. Right, we're back. We've just connected a signal generator up to the main input. We've got now the full span of the instrument on the spectrum analyzer. I'm injecting a frequency in at 2.51 gigahertz, which I think is this signal here, and you can actually do a peak to center frequency there, and then it'll pull it over, and then you can do to make it a bit better, we can do the span down here. We can make that then say 10 megahertz, and we can then do I think it's on here. Oh no, might be wrong. There's a couple function as well. Amplitude marker, span. Try and make that 1 megahertz then. Which is out of range for some reason there. Must be doing something wrong. Span. Let's try 5 megahertz then. Okay. We'll need to adjust the amplitude as well. So we'll probably get it round about the top line. Attenuator, our peak search, which is there. So it's put the frequency up where the peak is. It's highlighted that peak to center frequency, and then we can stretch that out a bit further. So we're at 5 megahertz. Let's try 4 megahertz, 3 megahertz, 2 megahertz, 1 megahertz, 500 kilohertz. Because we're modulating it with FM, we're starting to resolve now the FM modulation. Let's have a look now. 50 kilohertz, and if I just adjust the frequency now to get that right in the centre, which will be about there, I think. So already, you know, we're resolving what is an FM modulated carrier, and we've got the frequency readout. Some of the features that we've got on this, we've got a start frequency and a stop frequency as well, so we can put that in, which I'll do shortly after this. There's obviously the peak to center frequency. There's a center frequency step size as well, which in this case is 1000 megahertz. I think it's got 1 megahertz. We've got a band here. We've got high pass filters on and off. I think that's mainly for the cellular side, to be honest. Amplitude marker, peak search as well, so we can find the peak with the marker, or we can move the marker as well, the red dot, which you can see there moving along, and you can then measure the levels as well, which are indicated at the top here, along with the marker frequency as well, which is changing obviously. So we can look at all kinds of different signals. Quite a fully featured spectrum analyzer. Amplitude as well. We can set up things like reference level, step size, display line, different levels, display line on and off. So we've got a line there, green line going across for display levels. So when you get into it as well, you can really, you know, You can change the dBs per division, 2 dBs per division, 1 dB per division, 10 dBs. I think as well in the marker, I think there was a delta marker, so it'll put that where the marker is at the moment at obviously 0 level, and then as you move the marker from that point, then it'll take the reference level which you've started at and compare it against where you're at now, and it'll give you the dB difference. So that's good as well. Plenty of measurements can be done with delta markers, especially when you try and find the 3 dB points, which on here is around about there where the 3 dB point is on either side of the signal. So there's quite a bit that you can pull out with it really. Amplitude side of things, there's the attenuator, so we can either make it a manual attenuation or automatic. In the frequency side, we've got center frequency, step size, peak, stop start frequency, center frequency. There is also, I think, coupled function as well for resolution bandwidth. We can adjust the measure at resolution bandwidth as well. So, you know, you can get quite in depth on it. I'd say it's as featured as a Hewlett-Packard dedicated spectrum analyzer, definitely. I mean, resolution bandwidth now is at 300 kilohertz, 1 kilohertz, 300 kilohertz, 3 kilohertz. You know, again, we've got that lots of capability. You know, I mean, it's really is very good. All auto. You know, you can get into trigger, trace time, trace frequency, coupled function, trigger gate. You can trigger things on time, or trigger source. You can trigger on frequency, or on. You can do trigger source, video IF external, trigger return, gate setup, gate length time, so pulse signals, you can measure that. Lots of different features in that bit alone on the spectrum analyzer. So we'll see if we can pick off some off-air signals. Whatever signal you can pull out, you can demodulate it as well, I know that. So we'll use the AUX ports now to see whether we can pull off some off-air signals and come back. Okay, we've configured the instrument now to use the AUX ports, and what I've done, just as a makeshift antenna in the room, is I've attached a piece of solder just to the input and just run it along the bench just to see whether I can get the spectrum analyzer to pick something up. So what we'll do, we'll head back now to the spectrum analyzer, so that's with the main function, spectrum analyzer, and we've already got a frequency which we were looking at earlier, 98.9 megahertz, which is BBC Radio 1's radio station. We can see it there being modulated. We can increase the span to say 20 megahertz in this case, and then we can see all the other broadcast signals that are there. But what would be nice to do, and I'm sure I can do it, is to pull one of these signals out and then listen to it as well. Now, I'm not sure if it's tested as a speaker in it, to be honest. It may have, it may not, but I'm sure there's a socket on the back where signals that are demodulated can be passed out. There's certainly a TX monitor on it, so it may be that the TX monitor can tune into the signal even if a spectrum analyzer can't demodulate it directly. The TX monitor will be able to do that, and yeah, so quite interesting to be able to pull signals off air and at least look at that. So, you know, I could open it up to full span, for example. I just saw a pulse here actually just a moment ago, and if that's going up to nearly 3 gigahertz, because that's 2.9, oh sorry, center frequency, Ah, that's 1.5, so I bet this is my Wi-Fi router on about 2.4 gigahertz. That'll be pulsing off there, I think, roughly. Around here, yeah, it is 2.4 gigs. So it's just picking up my Wi-Fi route as it's sending a burst of transmission out. But yeah, I mean, it's great. You can look at car key fobs on it. Obviously, pick out any radio frequency, radio spectrum. Obviously, it goes right down to 300 kilohertz, so you know you can pick up all sorts of things, as well as HF, VHF, UHF, instant microwave spectrum. I put a start frequency in of 88 megahertz and a stop frequency of 108 megahertz. So I just picked out the broadcast band, for example. But I think there's also like the digital terrestrial television band for television. I think that goes up to about 800 megahertz. So again, we can pick out the multiplexers of the television signals. It's been broadcast off the TV. So there's all sorts of things there. We could put that span to 20 megahertz, for example, I think, and we can see if I alter the frequency. There's a bit of a multiplex there that's quite weak, and but if we just go up 600 megahertz, 650 something megahertz. There's another one here. I think there was something on around about 550 megahertz, if I remember. 550 megahertz. Oh, maybe I'm wrong. I'm sure I saw something around about 500 megahertz. Let's just open it up to 100 megahertz. Yeah, right there, look. So, for example, I can probably do a peak search. Found that, and then do a center frequency. Peak to center frequency. Then change the span again. Alter the span to something like, say, 50 megahertz. And then we can drag that out even further. So let's have it at 20 megahertz then. So 10 megahertz. So now we're getting the full multiplex, which is there. So all the television channels are in that, obviously, on that particular multiplex. So we'll increase that to 50 megahertz. And then there's another one. Peak center frequency, peak search. Peak center frequency again. Marker. So that's 573 megahertz. And that's way up there. So marker to center frequency, we normally want that. Marker on, marker off. Trigger. So marker to center frequency, there we are. So we can pull that one in then. So again, these are all multiplexers that are out there. Wonder if we can see anything on the amateur radio frequencies. Let's do 145 megahertz. And there's definitely something going on around amateur radio, the look of it. Something here, I don't know what that is. So we can have a look at the marker. Just move that down. That's 138 megahertz with the look of it. Some weird signal there, I don't know what that is. Let's have a look, 10 megahertz. It's gone. So, don't know why. Oh, that's why it's jumped to 145. 140 megs now. And then we've got something down here at 138. I think I saw. I think it might just be noise. We'll look at that. So we'll have span again. We'll open it up to 100 megahertz. And there's something here. Marker again. Let's have a look, see what we've got. Oh, they're all the broadcast signals. They are in the broadcast band. And that did look like it was something though, that, I must admit. That definitely said 137 megahertz. So 108 to 136 is aircraft, aeronautical band. Up to 144 megahertz is when the amateur radio band starts in the UK, to 146, and then this is all the PMR, private mobile radio, commercial frequency bands, and then we go off into others. There's some pulse thing happened there. So yeah, quite interesting, being able to pick out quite a few things. I don't know if we'll pick up BBC Radio 5 Live on 909 kilohertz. Can't seem to see that. Sorry, that's frequency span, that's why. I'm an idiot. 909 kilohertz. Out of range, it says. Oh, of course it is, I forgot. It goes down to 300. Well, it should get it. It says 300 kilohertz to 3 gigahertz, so unless the spectrum analyzer can't go down as low as that. Start frequency 300 kilohertz. Out of range, start frequency 1 megahertz. Is it 10 megahertz, I wonder? Yeah, I think the spectrum analyzer on this, oh no, I thought it might start at yeah, starts at around about 6 megahertz. I think it does, or 9 megs. Start frequency 6 megahertz. Out of range, it says. So I think it starts at 9 megahertz, 10 megahertz does this spectrum analyzer, and goes up to 3 gigahertz. So yeah, interesting. Quite a few signals here still, and various other things we can pull out. I think what I'm going to try and do is, if I isolate BBC Radio 1's frequency, which is 98.9 megahertz, and then we reduce the span down to something like 2 megahertz, where we can pull that out. I think if I go to the TX monitor, because I can't demodulate that in this spectrum analyzer, I think there's a TX monitor function which is under TX House Tester, I think it is, Analog Tester, and then TX Measure, TX Frequency, and then we could put in RF Frequency. It's already 98.9 megahertz, so we could set that, and it seems to be getting something here. RF power, deviation FM, it's not reading any deviation, so I'm not sure why that is. Detect mode, return, demod, oops, demod FM, yeah, that's all set there. We're hoping, I'm not sure, you see, if there's a speaker inside the test set where you can pull out the audio then from what you hear on the carrier, but if not, I think there's a socket round the back that you can couple out demodulated AF from the demod board and connect it to an audio speaker or a AF analyzer. So we'll have a look at that. But if I go to the AF oscillator, AF level, set amplitude, distortion, RF frequency 98.9, so I'm not sure if it's we'll be able to demodulate it, to be honest. I'm not adjust range. Now then, so it's picking that up now, 98.9. It's reading then all the AF distortions, etc. But as I say, I can't hear anything, so I'm assuming under deviation it's definitely getting the frequencies demodulated, the content, the FM content. So it must be that it's it must be there. Blank screen detect relative. It doesn't seem to be. It's just demod. Doesn't seem to be a feature from what I can see to decouple the modulation or the audio content. So what I'll do, I'll have a look around the back and I'll see whether there's a socket that we can feed off to a AF amplifier so we can listen to what the monitor's picking up off air. So just bear with me. Okay, we've managed to find a socket on the back, which I'll, when I get to that section of the video to show you all the sockets, you'll see that there is a socket on the back for demod output, which I've now connected up to my other test set, which has got a speaker in it on the F input, which I'm going to show you. We're tuned into a BBC radio station at the moment, and it's demodulating that off the carrier, as we saw on the spectrum analyzer. So I've coupled the AF output from the back of the instrument up to the other test set that we've got here, and this is the signal that's been demodulated on there. Now if I turn the volume up on the thing, I'm picking up music. So looks like we're getting it. So that's a modulation that's been recovered from that carrier. So yeah, and so it has actually demodulated it off air. So in theory, I think if I go back to the spectrum analyzer, I might be able to still look at that and demodulate it too. I don't know, just making funny sounds. So you've got to be in the RF analyzer section in order to demodulate it, I think. Unless the span is reduced maybe to 1 megahertz. 50 kilohertz. Oh yeah, I'll pick it up there. So there we are. 20 kilohertz. So we can tune off. Let's do 94.9 megahertz. What is it? 93.7 megahertz, I think.
Do remember that because people have got followers and good reviews.
No, 1.1. So yeah, that's just off the spectrum analyzer. So I'll just turn that down just in case I get a copyright claim on the YouTube video with the music playing in it, you know, things can happen. So yeah, very interesting. So you can basically use the instrument to tune into any radio frequency and then obviously demodulate its content, be it analog or digital, and quite useful in that context. So we'll go back to span. If I go back to the RF analyzer, which I think was analog tester, and then we've got TX measure. There we are. You have to press it there. So yeah, it's picking it up. So you can see there we've got distortion, all sorts of levels. Right, we'll come back with some more measurements, this time using the signal generator output from this instrument as well. Okay, we've gone to what is the analog tester and then selected TX measure, and then we've inputted a frequency which is coming from a signal generator, which is that one, 2.510 gigahertz. So we basically went what is TX frequency, RF frequency, and then we entered the frequency in by pressing this button, and we entered that frequency in, and basically this tells us a frequency error. So if we start to wander off frequency with the SIGGEN coming in, or the transmitter that's been measured starts to drift off in frequency, the error will be measured here below it. We've got the RF power level, the signal level that's been received, the FM deviation. We're actually producing 10 kilohertz deviation from the SIGGEN, and it's being read there at a mod frequency of 1 kilohertz. That's the RMS value, whereas that's the peak value deviation FM. That's the RMS. That's the mod frequency which we're receiving. Now the demod output on the back of this test set, I've coupled then to the AF input of my other test set, and this is the recovered audio, the 1 kilohertz audio from that measurement. So that's been received on the AF input there. So we can demodulate any signal that's coming out the back of the test set, and obviously, you know, couple it into an audio amplifier, or in this case I'm using the AF Analyser on the test set. So yeah, very interesting. So that's a little rundown of doing TX measurements, where we're transmitting a signal in and we're measuring the frequency, the error, deviation and RF power. So please bear with me now. We'll do the other measurement. This is generating a signal out going to what would be the other test set, and we'll look at that next. Okay, just before we show the output signal coming from here, just wanted to show you that as well as down here with the analog tester spectrum analyzer, we've got the TX and RX tester, and when we go into there, then it'll set up the instrument for mainly cellular measurements actually, which you can see on this side here. But one of the interesting things is there's RF power and there's power meter. If you look at power meter, we've got a signal coming out of my signal generator over here at 1 gigahertz. So if I put in the TX frequency, which is already in actually, but if I re-enter it 1 gigahertz, and then we do an auto range, and it's actually got an inbuilt power meter. So we're reading the dBms and the milliwatts range, and then we've got other features that we can set up here. Adjust range 0 set, range up, range down, set relative. So there's all sorts of little goodies, and of course you can put in any frequency you want between those limits. So yeah, very interesting. So I'm not sure what that does. RX output level, RX output frequency. So yeah, you can obviously set a SIGGEN up as well. And I think as well as that, even under the analog tester, I think when you go into I think you can do not just TX measure, but under TX measure with signal generator as well. So you can actually break the screen into two, a bit like a Marconi 2955, where you can obviously put in the RX frequency that you're generating, the deviation, type of modulation, FM, etc. And then as well the transmit size measured here in this area, receiving this area. So then you can set up your TX RF frequency, level and power, deviation and such like, and yeah, you can go into all sorts of things, and there's different menus as well, available sub menus, so quite interesting. But yes, this power meter can be quite useful under this mode, which I didn't know it had, to be honest. But I'll have a look at the RF power as well. I don't know what that is. Let's have a look. Right, we'll put the TX frequency in then. That's also set to 1 gigahertz. 1 gigahertz. And calibration, auto adjust. Adjust range. Let's see what it does. Execute. It's not done anything, but well, it would. I'm not sure. Window, frame, rising time. So I think there's other features that you can do probably. Marker, normal, TX reference level. Perhaps adjust that. Minus 10 dBm. Set. So it says level over. So if I do the TX reference level again, set. What does it do now? Adjust range. Normally when you adjust range it finds its best level. So I'm not sure about that, to be honest, what that does, but wait, says level, relative, recall, setup template, so there you can get your rise times, etc. for a pulse, and all that's standard. So I don't know. Perhaps that reads pulse if we turn the carrier on and off. Oh, don't know what that is. So yeah, interesting. So under the TXRX tester there's a power meter there. At least that's useful as well. So yeah, we'll go to the SIGGEN now and see what kind of output it gives to the radio test set. Okay, we're in the signal generator mode now, which is under the analog RX and TX tester. We can set up now the RF frequency, which I've already set at 500 megahertz. The RF level goes as low as neg 133 dBm, or in microvolts. I'm not sure what that is. Let's have a look. See if it'll give it in microvolts. Neg 20 dB microvolts. So in EMF, but neg 133 dBm with no mod on at the moment. So we can select modulation, oscillator 1 kilohertz, frequency is 1 kilohertz, deviation is off, so we can set that to on, I think it is, just 39 kilohertz. So we'll try and reduce that. Not sure how you do that, to be honest. Unless there's some way of being able to get the cursor across. Perhaps if we press that again. AF oscillator, AF level. Adjust range. Modulation. Unless can adjust that. So oscillator 1 deviation. That's it. Then we'll set that to something like 2 kilohertz. That's it. RF level. And we'll wind that up now so that the test set can pick it up. To lock onto it now, so we're getting a signal there, and if I I can just zoom in. We're putting 2 kHz out, it's reading 2 kHz as well. We've got, I think on the scope, 2 kHz as well. Frequency is accurate, and the level obviously. And have a look at the spectrum analyzer, for example. That's all correct. So yeah, that just gives you an idea of you know, the output level, and the attenuator is fairly crisp with the signal. I'll stop moving the camera. So yeah, can adjust the RF level quite easily, right down into the noise floor there. So yeah, that gives you a demonstration. I can move the RF frequency as well, in, you know, 1 Hz steps, and back the other way. So got quite a bit of control. Lovely. Okay, we're back again. This is the rear of the instrument, and I was telling you earlier about there's a socket on the back for the demod output. Well, that's obviously the one that says demod output there, which is this one. So as far as the BNCs are concerned, we have a number of them. We've got what is a external trigger input as well for the scope, I think. External trigger output, external FM input, demod output, bit error rate input, data and clock, detector output. We've got CDMA references, and along the bottom here we've got a 10 megahertz or 13 megahertz frequency input for the locking of the instrument to lock it to frequency, and a frequency standard buffered output, serial port, parallel, and we've got GPIB, and this here is a CDMA testing port, the IEC mains plug. We've got the main switch on and off as well, and we've got the fuses for the IEC here, and an earth lead as well. So yeah, pretty good. Well, I paid for this test set the grand sum of £100, so that's how much I paid for this test set. So very cheap indeed, and just shows you. Picked this up from a radio rally. I think it was the Newark, the National Hamfest at the Newark Showground some years ago. Got that for £100, not bad. And the guy who was selling it was selling other test gear as well, but with this being mainly a cellular test set, he wanted rid of it because it's not really something that's sought after, you know, in the RF test world, for, you know, getting into electronics engineering, RF engineering. But as you can see, it's a fully featured test set. Now, obviously, you know, it's not built for field service. It's not the kind of instrument that you'd take to a hilltop radio site, for example. But it's a big beast. I mean, this weighs, as I say, about 2 to 3 times what that test set is there. You could, I'm seriously not exaggerating either. This is extremely heavy, and it's a very well made instrument, but it's also very impractical for carrying around. So you wouldn't take it outside, you know, to a radio site or whatever. I've got an old crack box here which I'm using to stand it up a little bit. But one thing I have noticed about this instrument, for all its bells and whistles and everything, I can't seem to get an oscilloscope to show on the display. There doesn't seem to be that option in the menus anywhere. But although it can give an AF output, which I haven't demonstrated at the moment, and an AF input, and you can read the AF frequencies and you can give AF levels out just with the data that's on the screen, there isn't an oscilloscope like you get on other radio test instruments. Now, whether I'm missing something, and there is a hidden scope somewhere which I haven't yet worked out to get to, because obviously it is a complex instrument with all the sub menus and secret little hidden menus all over. I don't know, unless it's something I'm missing. But obviously, if anybody else has got one of these test sets, if you want to leave a comment in the below, you know, telling me where I can find the oscilloscope in it, if it does have one. But I cannot find the oscilloscope anywhere in it. It doesn't appear to have one. But yeah, lovely test set. Nice deep test set, about the same depth as a Marconi 2955, maybe a little longer. About an extra 7-8 inches wider than a standard radio test set, I would say. Maybe not as much as that, maybe 5 inches, but you know, it's a fully featured little test instrument. It can take 10 watts on the input port, so if you're going to put more power into it, then you can obviously put a bigger RF attenuator on the input. But yeah, really, really good. So, you know, anyone who's wanting to get into doing RF measurements and testing, you know, if you're a student, a young person that's interested in electronics RF work, to be able to get a spectrum analyzer as fully featured as that, up to 3 gigahertz, and as well the fact they can demodulate off-air signals. You've got a signal generator, power meter, TX monitor, you know, so many features in this test set just as it is. If you can pick one up for £100 like I have, you know, you're on a winner. So yeah, this is the state of things, you know, that yeah, you can have it on the bench. It doesn't appear to have a stand underneath. There's no legs that fall down or anything. This is obviously meant for a automated test environment in a manufacturer's laboratory or something, you know, when mobile phones are being produced, they're being tested on jigs, a bit like the HP 892122 test set that I've already done a video on. If you haven't seen that, please have a look. But from what I can fathom, these do come with a spectrum analyzer standard, whereas on the HP range of cellular test sets, that's an option. So sometimes you can get duped by that. So again, very good purchase is the Anritsu. Extremely well built to last. Very nice display. Although I have noticed on the rear panel there isn't a VGA output from what I can see. So there's no way you can replicate the screen on a bigger screen, which you can on a lot of the other test sets today. But well, you know, I just thought I'd mention it. But you can at least see the screen, it's quite clear, and it's a nice colour scheme. So yeah, very, very well worth having. A smashing little test set. Something that could give you lots of years of good service. And as I say, it's probably programmable through the software, that you can set it up for other systems as well. Maybe even make it into a proper radio test set, because it's funny how it has the term radio communications analyzer. And I have seen Anritsu do a range of RF test sets that are very much like the Marconi test set, that are in this style, this package, except they've just got, you know, different readouts on the screen here, more like an analog radio test set as opposed to a cellular one. So it may all be via software that you can upload a new version of firmware, and also upload perhaps analog test software onto there as well for PMR radio systems, private mobile radio systems. So there's perhaps a lot more capability in it than perhaps we give it thought for. So thank you for watching the video. If you like it, please subscribe, and please give your comments in the video if you know anything more about these test sets and whether they've got an oscilloscope built in. But as I say, I can't find the oscilloscope, but it reads everything you could possibly want. So again, I fully recommend it. You know, if you want something that's got a nice spectrum analyzer, an RF gen, obviously a TX power monitor and a TX frequency monitor, demodulator. You've got it all in this test set. So thank you for watching the video, and see you in the next one. Bye now.